Huh. Well, I am plugged in. That's weird. It might be 5%. All right, so let's look at the law of cosines. Here are your three versions of law of cosines. And you should kind of be able to look at that and sort of see some patterns. Hopefully you're noticing if you've got b's and c's that are squared, then you have a b and c here that's multiplied by the cosine a. When you have a's and c's that are squared, you've got an ac that's multiplied by the cosine of b. And if it's a squared on the left, then it's the cosine of a on the right. If it's b squared on the left, it's cosine of b on the right. So some patterns to help you to try to memorize that. All right, so our first example is the case where we're given side angle side. So the angle that we're given here is 25 degrees, that's angle A. And then side B is 15 centimeters, and side C is 10 centimeters. All right, so we've got a triangle. We can see that law of sines isn't going to work here because while this is a known angle, that's an unknown side, and while this is a known side or this is a known side, the angles opposite are unknown. So that would give you two unknowns in the same proportion. So that's not going to work. So we're going to use the law of cosines to find this opposite side right here, because that's really the only thing that we can do. That's the only way we can substitute into one of these forms of the law of cosines and just have one variable. So we're going to use this version right here. So we have a squared equals b squared plus c squared minus 2bc cosine a, and then just fill in the blank. So a squared equals, our b is 15, so we have 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 25 degrees. So grab your calculators. I want you guys to play along. And let's go ahead and calculate the square root of that whole quantity. So the square root of all of that stuff is going to give you your a value. And we remember when we take the square root of both sides of the equation, it's always the plus or minus square root. But we're going to take the plus square root, positive square root, because it's a distance. Even. 7.287. Anyone else have that? Anyone else get that? Got that as well? Okay. All right. So now here's our little thing that we were talking about yesterday. Remember, you want to retain as many decimal places as you can in the process of doing your computation. And then at the very end of your problem, that's when you're going to round to the nearest, like, 3 decimal places. So you want to keep that figure in your calculator as it is with all the, however many other decimal places. And then remember to use the second answer feature of your calculator when we do our next calculation. We're going to use second answer. Does anyone not know how to use second? Not familiar?
I go back and I
You just retype it all.
Second
No,
answer,
not
like
do that.
Second, and then you hit the
yeah.
answer key. Yeah, to pull up the previous computation from your calculator. Yes.
You can hit the STO button, and it's a lot easier.
You can store. Yeah, we can definitely do that. So if you want to store, so you can, once you have this, you're going to hit store, and then you hit the alpha key and whatever letter you want to store it as, and then you can recall it later. So that's fine. So you can store that value as A, and then you can store the next one as B, store the next one as C. Maddie, what's that? Store STO, it is right above the on button of your calculator. And then the second feature, that is recall. So whatever is the number that's on your home screen, whatever's the number on your home screen, you can just hit store. And I don't know if it already pulls up the alpha or if you have to type alpha. Store, no, you have to type alpha and then choose whatever letter you want to store it as. And then anytime you recall that letter, it will come up as the number that you stored.
Do you have to?
No, not at all. It just saves you writing down a lot of decimal places. All right, so whatever is your method for having that number captured, let's move on to the next step of the problem. So the first thing we did was we figured out the side opposite the given angle, used law of cosines. And now the law of cosines is pretty messy. There's a lot going on there. The law of sines is like a lot simpler to use. So typically at this point we use the law of sines because now we do have an angle and an opposite side. So as we think about that, if you look at what's given, I could use this angle and this side and this side. Or alternatively, I could use this angle and this side and this side. But whichever way I use those quantities, I'm in the midst of that ambiguous case because I have angle side side. So I want to make sure that whatever angle I come up with, I won't know if the actual angle is supposed to be the acute angle or the obtuse angle. So the easiest way to resolve that issue is to choose from among the two angles I'm going to solve for. I'm either going to solve for angle B or I'm going to solve for angle C. And the easiest way to avoid that whole ambiguous case is to solve for the angle that you know has to be an acute angle, couldn't possibly be obtuse. And then to get the third one, you can just subtract from 180. So if you look at the two possibilities, angle B or angle C, which one of those has to be an acute angle? C has to be, because it's opposite the shorter of the two sides, okay? So if one of these is possibly going to be obtuse, it would be B. So let's solve for the acute angle. We know we know we'll get the right answer that way. And then just subtract from 180. So this is kind of key right here. This step right here is sort of key to solving the cosines problems. So we're going to solve for the angle opposite the shortest side. So we're going to solve for angle C. So I'm going to write sine C over C equals sine 25 degrees over side A. And we can fill in some numbers and I'll multiply both sides by C. C's drop out. You get sine C equals the sine of 25 degrees. And then side C was given as 10. And side A, we've labeled our diagram as approximately 7.287, but we have a much more accurate version of that number right in our calculator. So if we call it up with second answer or with recall, whichever way you prefer to do it, and they're both just fine. The nice thing about storing and recalling is once you store it, you can do all kinds of other computations, and you can recall it 2 or 3 or 4 computations later. You don't have to worry about it being the most recent calculation. Okay, so once we have all that, then C is equal to the arcsine of all of this. So put this in your calculator if you would please, and tell me what you get for the angle C.
35.45.
35 point, can I have 3 decimals?
35.445.
445. Okay, anyone confirm that? Does anyone else have that? Okay, great. So if our angle C then is 35.445, now we can find that third angle quite simply. Does anyone have that yet?
119.74.
Okay, 119.55.
Yeah, 554.
Okay. All right. Or maybe 555 if you round it up.
Yes.
Okay. All right, so there you have, we've solved our triangle, we use law of cosines, and then we use law of sines in the simplest way possible, and we have all of the sides. Certainly, the diagram was just a schematic. It's not drawn to scale because it looks like angle B should actually be an obtuse angle. So that problem. All right, so let's go to the next case. So that's given side angle side. So let's go now to the case of side, side, side. So, in this case, for this example, I have side A is 15, side B is 18, side C is 22. So I can just draw kind of, you know, a little diagram. I have 22 and maybe 18 and maybe 15 comes off, something like that. So here's A equals 15, here's C equals 22, and here is B equals 18. And now, for this problem, again, once I've solved for one of the angles, I mean, whatever angle I pick, if I choose this angle, then to find another angle, I have angle side, side, angle side, side. If I chose this angle, I would have angle side, side. So I want to avoid that whole dilemma of the ambiguous case. So in this case, what I can do is, I know for certain that if there is an obtuse angle in the triangle, it will be opposite the longest side. I know for certain. So if I use the law of cosines to find the angle opposite the longest side, and there's no ambiguity with the law of cosines. So if I use it to find the angle opposite 22, then the other two angles will have to be acute, and I can just use the law of sines for those, and I will have no problem. So I'm going to set this up using law of cosines for angle C. So to do that, I need to use this form of the equation. C squared equals A squared plus B squared minus 2AB times the cosine of C, and then plug in all of the given information. Or we could even solve for cosine C generally in this equation and then plug in everything. So if I was just going to solve for cosine C, I'm going to subtract A squared and B squared over to the other side of the equation. And then I'm going to continue solving for cosine C by dividing by negative 2AB. So divide by negative 2AB. And now I have cosine C equals all of the above there. And then I can find C just by taking the arc cosine. So C equals arc cosine of, now I'm going to fill in my values. C squared is 22 squared minus A squared, which is 15 squared, minus 18 squared, and then divide by negative 2 times 15 times 18, making sure to put parentheses around that denominator, so you're, and your numerator, so you make sure you're dividing, take your numerator and divide that whole numerator by that whole denominator. So does anyone have an answer for angle C?
42.599. Would anybody? Yes.
42.599. Anyone else have that?
Anyone?
We're working on it. We're very speedy today. Did you get that?
I got it.
Oh, you got an error?
Come on, Sam.
I didn't write it out.
Okay,
like
so
that, but
did you remember this negative here, or you didn't write it out like this?
I wrote that different. Like I solved each different step for it.
Oh, instead of putting it all together? Okay, what'd you get, Nina? Oh, okay. All right. Okay. No problem. Okay, we'll take a look at what you have there. So, Nina, can you say that again? Okay, so 83.087 degrees. We're going to hang on to that for C. And then hold on to some of those decimals because now we're going to solve for another angle. So at this point, we know both of the other angles are acute, so it doesn't matter which we solve for using law of sines. So let's go ahead and maybe I'll solve for this angle over here. I'll solve for B. Doesn't really matter. So solving for B, I'm going to have the cosine of, oops, I want to pick the sine, make sure I'm using sines for the law of sines. So we have the sine of B divided by side B, which is 18, and that equals the sine of C, and I'm going to put that right here on the board as second answer, because that's what I want you to use when you make your calculation. Joe?
Could you just plug in bigger numbers for the cosine and then get another angle and make it
You can usually, yes, I would say that works, but make sure you've solved for the obtuse angle first, because if you haven't solved for the obtuse angle first, sometimes you run into trouble. Okay? All right, so sine of second answer over 22. Okay, so now solving for this, we have B equals the arc sine of, when I multiply both sides by 18, I have 18 sine of the second answer, whatever that was, divided by 22. Okay, does anyone have an angle B? And definitely degree mode. Alex?
54.315.
I concur. Great. All right, 54.315. So just remains to find angle A. Can someone subtract those two from 180? Tell me what you get for that.
42.598.
Okay. 42.598. Anyone else? Okay.
Yeah.
All right, perfect. So we've solved for, we were given the three sides, and we solved for the three angles. They're definitely all here. Here's angle A, an angle B, an angle C. Okay, the last thing in today's lesson is just taking a quick look at Heron's formula, which I already spoke about a little bit. So Heron's formula is right here. So if you were trying to solve this problem right here, finding the area of a triangle, we've got three sides, we've got the formula. S is our semi-perimeter, and the area is just the square root. So this should be like, you know, super easy, no-brainer, nice points for your test next week, so don't miss this. All right, so you start off finding the semi-perimeter, because that's called for in the area formula. So just add up all the sides, and like I said before, adding up the sides is the perimeter, and then the semi-perimeter is just going to be taking that in half. So you have, looks like 33 halves. Good, so 16.5 for a semi-perimeter. And then we're just going to plug that into the area formula. So the area is equal to square root of 16.5. And then I have 16.5 minus 14, so that's 2.5. And then I have 16.5 minus 10, so that's 6.5. And then I have 16.5 minus 9, so that's 7.5. And I find it easier just to do that little subtraction first. It just means less typing in your calculator. And then, anyone have an area? 44 point.
84.
Can I have a third decimal place?
Oh, 8430.
843. Okay. And there were the units for meters, so what's the area in meters? Squared, right? Okay. Meters squared, or square meters. All right, I'm going to end this.